Hi everyone. So today in this session, I will be talking about Coulomb's law. Before that, I would like to remind you. So whenever you were in childhood days, we used to play some games. So when you take two stones and rub these stones and bring it close to each other, so we feel that there is a force in between them. And also, if I take another example, if you take a comb and comb it for a long hair and bring it to the small particles, near to the small particles like papers, they tend to attract to the comb. So from this, what we understand is, whenever you bring two charged bodies closer to each other, there will be some force, attraction or repulsion, there will be some force between them. So what is the amount of force between them? That is what Coulomb's law gives you. Coulomb's law talks you about what is the exact amount of force between the two charged bodies. So in this session, I am going to deal with that. So let us derive Coulomb's law, state and prove Coulomb's law. So directly we will go for the derivation of Coulomb's law. First we are going to state and prove Coulomb's law for 2-point charges. So what does this statement tells is, if you consider any 2-point charges, so it is Q1 and Q2, then so the force between them, so the two charges Q1 and Q2, if you consider, then the force between them acts along the line joining the two charges. So which means that, so it talks about the direction. As all of us know, force is a vector quantity which has both magnitude and direction. Therefore, it will act along a line joining. So this tells you the direction of the force. Whereas the magnitude is given by, the force is directly proportional to product Q1 and Q2. So it is directly proportional to Q1 and product of Q1 and Q2, and inversely proportional to square of the distance between them. So with this statement, so let us build a mathematical equation. First let us talk about only the magnitude. Then so F is equals to the force between the two charges. What does it says? The force is directly proportional to product of Q1 and Q2. So it is product of Q1 and Q2 and inversely proportional. Therefore, it is divided by square of the distance between them. So if the distance between them is r, then the square. This is an example I considered. If this is Q1, so and some other charge, this is Q2, then the distance between them, let us consider it as r. Now, so between these two charges, the distance is r. So force is directly proportional to product of Q1 and Q2, inversely proportional to square of this distance. Therefore, it is r square. So this is the statement of Coulomb's law. I have not talked about the direction of force yet. It is only the magnitude. This proportionality can be removed by introducing one constant. So that is F is equals to, I will introduce in place of proportionality, I will introduce a proportionality constant K. So which is equals to K into Q1 Q2 divided by r square. This is the distance between those two. So now what is this K? Is the proportionality constant, which can be equated as K is equals to 1 divided by 4 pi epsilon. So what is this epsilon? Is epsilon is called the permittivity of the medium. So what is this permittivity is? It is the ability of the medium. It is the ability of the medium so to propagate. It is the ability of the medium so to propagate. So epsilon is called the permittivity of the medium, where epsilon is equals to epsilon naught into epsilon r. So this is called relative permittivity. This is called relative permittivity. So whereas this is absolute permittivity. So now if I consider the medium of propagation, so if the medium between the two charges, if the medium is free space, let us assume, or vacuum. So if the medium is free space, then so epsilon r, the relative permittivity, is equals to 1. Therefore, so what is epsilon becomes? So it is just epsilon naught. So epsilon just becomes epsilon naught. So which means that, so if I substitute this, so if I call this force equation as equation number 1, so the propagation constant is k as 2, and so for free space, so epsilon equals to epsilon 3. Then the force is equals to, so in place of k, I will substitute 1 by 4 pi epsilon, where epsilon is epsilon naught. Therefore it becomes, so numerator is q1 into q2 divided by, so you will get k as 1 by 4 pi epsilon. Therefore 4 pi epsilon naught for free space into square of the distance between them. So this is called the force between the 2 point charges q1 and q2. So this will give you only the magnitude of the force, but we all know that the force is a vector. So let us represent, so what is the vector form? To represent this in vector form, let us consider the two charges q1 and q2 separated by a distance r. Now this is the observation point, which I call it as a reference point. This is called observation point. So I am observing from this point. So if the distance from observation point to q1 be r1, if the distance from observation point to q2 be r2. So now, so if I want to calculate the direction, so as the statement says, so it is acting along the line joining the two charges. This is charge 1, charge 2. So line joining these two charges is this. If I consider there is a positive charge q1 here and the similarly positive charge q2, and I am finding what is the force at this charge q2. Okay, so that is given by F2. Okay, so I am finding what is the charge at point q2 due to q1. Okay, so therefore I will modify the force equation. Force equation was, so F is equals to q1 into q2 by 4 pi epsilon r square. So I will rewrite that expression, that is F is equals to, so it is product of two charges q1 into q2 divided by 4 pi epsilon naught, because I assumed it is a free space, into r square. This is only giving you the magnitude of the force. So if I want the vector, then I will write, so vector F is equals to q1 q2 by 4 pi epsilon r square into unit vector, so AR. So since it is from 1 to 2, so I will write it as, so A unit vector from 1 to 2. Similarly, so now I want to calculate what is unit vector A12. So we all know that unit vector is any vector, that is a distance vector between those two from 1 to 2 divided by magnitude of that vector, that is R12. So I am going to consider only the magnitude. So we, in the previous video, I have defined what is unit vector. So I will post this link of that video in the description, you can see. So that is vector A, unit vector A12 is equals to, so that is the vector r, the distance between those two vector, divided by magnitude of that. So which will be equals to, so what is this vector r12? If I want to specify vector, then it is given by, so it is vector r2, because I am observing from the observation, I take it as a reference point. So it is r2 minus r1 divided by, so magnitude of r2 minus r1. So I only take about the magnitude. So this is called unit vector. So I can substitute, so what is the unit vector value in this equation? So I can substitute what is A12 in this equation. Therefore the above equation becomes vector f is equals to, it is q1 into q2 divided by 4 pi epsilon naught into r square, whereas unit vector will be replaced by this expression. Therefore it is vector r2 minus vector r1 divided by magnitude of that vector. So that is r2 minus magnitude of r2 minus r1. So this is where we are calculating the forces at point Q2. So we are calculating the force at point Q2. So therefore I call this as F2. So I call this as F2. So the force at charge 2. So I will call it as F2. Similarly, if I want to calculate what is the force at charge 1, then I will write it as F1. So which is equals to, see, the product of charges remains the same. It is Q1 into Q2 divided by 4 pi epsilon naught r square. The magnitude remains the same, but the direction, if you talk about, see, what is the force at the charge Q2? If both are positive, it will be repulsive. Therefore this will be away from Q1. So it will be moving from here. So it will be moving like this, and this is called your F1, the force F1. So if I want to find out this, then this becomes R1 minus R2. So because we are calculating what is the force at 1 due to 2. So F12. So therefore, so in the above equation, so I will modify this. This is as unit vector, okay, A 2 to 1. So the direction is from 2 to 1, charge 2 to charge 1. So again, from the definition of unit vector, it is vector r21, so which is equals to vector by its magnitude. So vector 2 to 1 divided by magnitude of, so that vector. So again, since we are observing from the observation point, so we can say, so this is equals to, so it is instead of r2 minus r1, it is r1 minus r2. So vector r1 minus vector r2 divided by magnitude of r1 minus r2. So again, if I substitute this in this equation, if I substitute this in the above equation, then I can rewrite this expression as, so F1 is equals to, so vector F1 is equals to, so I will write Q1 into Q2 divided by 4 pi epsilon naught into r square. So in place of unit vector, I will write it as vector r1, small r1 minus vector r2 divided by magnitude of r1 minus r2. So now if you compare this equation, the force experienced by charge 1 due to charge 2, if I compare this equation with the force experienced by this charge q2, charge due to charge q1 is, So they both are same. If you compare that, magnitude are same, q1 q2 by 4 pi epsilon r square, similarly q1 q2 by 4 pi epsilon r square. So you only remain with, so r2 minus r1 divided by magnitude, whereas this is minus r1 minus r2. So if you reverse these symbols, so negative sign comes out. Therefore, so I can write this as, so f1 is equals to, so f1 is equals to, so it is q1 by q2 divided by 4 pi epsilon naught, because it is a free space I assume, so into r square. So I will bring, so r2 minus r1, I will reverse the value vectors, so therefore minus comes out. Whereas magnitude, so it doesn't matter whether you write r1 minus r2 or r2 minus r1. So now if you compare this equation, so if you compare this entire part, so with the f2 equation, so they resembles the same. So if you observe, so it is, if you observe this equation, so it is r2 minus r1 divided by r2 minus r1. Here also you get, except that you got minus here. So therefore, so I can rewrite this equation as, so f1 is equals to, so force due to charge 1 is equals to, so minus I will take it outside. So this entire other terms, so I can call it as f2, which means that, so the force at charge 1 is equal to force at charge 2, but the direction is opposite. That is what we have seen in the diagram. So if f2 is moving this way, then f1 was moving away. They are repulsive force, we say. Okay, so the negative sign indicates they are repulsive. This is Coulomb's law applied for 2 point charges only.